Here is a Sony model DHR-1000VC DV VCR. DV, of course, stands for digital video, and I'm sure you all still know the good old MiniDV cassettes. Now, these are called MiniDV for a reason, and the reason is there are indeed full-size DV cassettes. Now, this one says DV cam, but the only difference between DV and DV cam is the higher tape speed for better reliability on the professional DV cam format. Other than that, these systems are identical, and most Sony DV VCRs and camcorders can actually play back DV cam. Now, if we compare these two DV cassettes to a good old traditional standard VHS cassette, you can tell these are quite small and delicate. And so this overhaul video of this DV VCR is going to be a bit different from my VHS VCR overhaul videos. When it comes to the mechanism of this VCR, I'm going to go with the simple strategy of if it ain't broke, don't fix it. On the electronics side of things, there is, however, one problem that is a matter of fix it before it's broken, and that is the switch mode power supply. So I'd like to take a closer look at that in this video. And then there is the DV port right down here, which is broken. I have tried it with various different computers, various different FireWire cards, different operating systems. I even tried different Sony camcorders. And with none of these devices, this VCR will establish a connection through the FireWire. So I'm hoping there is some obvious problem with the FireWire port, such as a bad solder joint. Of course, I won't be able to diagnose any problems in the data communications. And here is the mechanism, quite a bit smaller than VHS. The head drum in particular is absolutely tiny. And there is quite a bit of added complexity in the front because this VCR will in fact work with both the standard size and the MiniDV cassettes. And as you can clearly see, these are quite different, unlike VHS and VHS-C, for example. So the tape guides and the reel drives need to be in different positions for each one of these cassettes. And the VCR will switch all that automatically as you insert a cassette. So this is quite something, not something you want to mess with if you don't have to. But we'll come back to this mechanism later. Removing this side panel gives you full access to the power supply, and I can already tell somebody must have been in here at some point because the connections to this motor should be socketed right there. Instead, they're soldered straight into the circuit board. Look at that. Just look at that. This is where they soldered the motor wires to the board. That is terrible. The power supply module is out of the VCR. If you're doing this for your own safety, make sure this filter capacitor is discharged. Now, my filter capacitor is discharged because I haven't had this VCR plugged in several months. Now, the part that I'm interested in is the heart of the circuit, and that's inside this shielded box. So that's the next thing that has to come off. I have the soldering equipment preheating for that. And unfortunately, I'm not the first one to get into here, because the same genius that did that also did this wonderful kindergarten grade soldering. Just look at that. Isn't that fantastic? Well, at least I can already say no harm done to the traces up there. This should clean up okay. And I am glad that this person did not bother to resolder any of the numerous bad solder joints that I have already found on this board. The metal box has been removed, revealing this circuit board. This discoloration in this area is normal for these devices, and that's the reason why I originally wanted to take a look into here. Of course, now I have another reason to pull out this board, and that is some more ridiculously bad soldering. Here we have the board taken out, and yep, they did work on this. This is the primary side switching transistor for the switch mode power supply. And something went wrong in here, causing several components to blow. So we have, going by these crappy solder joints, we have 2 transistors that got replaced. We have a fusible resistor that got replaced, and we have the main switching transistor and its heatsink. That all got replaced, or at least it got taken out for testing. This right here looks actually fairly okay. It does have heatsink compound. Now, what can cause the primary side switching to blow up like that? Well, this little capacitor can cause a hiccup that causes things to blow if this goes bad, or bad solder joints in this transformer. Now, as we can clearly see by these solder joints, which are original Sony factory solder joints, none of these possible problems have been dealt with, thankfully, because otherwise the solder joints would look like this. But yeah, they they fixed this, but didn't take care of the root cause. The capacitors over here, again, the solder joints, they don't look too bad, so I'm willing to say these might be original. I doubt, however, that this hot glue is original. And then, to be fair, this right here, you can see one of the interconnects to the main board is just completely loose and fallen off. That is the result of a bad solder joint. That is Sony's fault. And yes, I know my finger looks horrible. That's what happens when you work with isopropyl alcohol. Disassembly is finally complete. So I'll now go and double check in the service manual that these transistors actually belong into here. And then I'm going to start rebuilding this board, fix all the solder joints, and replace the capacitors. And a couple of hours later, the board has been rebuilt, and I'm going to start off at the solder side because the difference should be quite noticeable on here. And I was even able to salvage all the traces going to the transistors. They had lifted off the board, but they still work, and they do hold the transistors in place safely, so no wire bridges required, thankfully. Resoldered a bunch of bad solder joints, or questionable solder joints. Obviously, I wasn't able to salvage this one, because, well, there is no more copper left on the board. Now, on this side, the difference is less noticeable. The transistors all turned out to be the correct type, so at least they got that right. The secondary side capacitors are still in place, as you can see. I unsoldered all of them, put them on the tester, and they're perfectly fine. Some of them showed up as having 0 ohms ESR, They're all rated for 105 degrees Celsius, so there is no point in replacing them. They're fine. Now, the capacitor that was not fine at all was the small one right here, which I said may have caused the power supply to blow up in the first place. This is a replacement, also rated 105 degrees Celsius. The original one is this one right here, 2.2 microfarads at 50 volts, only rated for 85 degrees Celsius. And if we put this on the tester, as you can see, yeah, half the rated capacitance and 140 ohms ESR. So yeah, this thing is probably more of a resistor than a capacitor. Here is an example for what I would call bad solder joints. Now, they're not bad in a sense that they keep the device from working. They're still okay, but you can see those lines, and these are already like weak points. Along those lines, the solder joint will eventually start cracking, and that is when trouble begins. So right now, it's easy to fix it. Just flow some more solder onto these joints, and that's it. The 3 boards have been thoroughly checked and repaired wherever necessary. Time to put everything back together. The power supply is back together, back in its place temporarily, because out of the 6 solder joints of this metal cage, I only soldered 2, just in case something does go wrong and I need to get back into here. So either way, the power supply will have to come out again once more, but right now it's time for a test. Okay, here we go. This now has the potential to really ruin my day. Let's apply power. Oh, that's looking good. Yep, going into standby. That's what it should do. Power it up. And play. I'm not sure if there is anything on this cassette. Oh, we got time code. Seems like it's working. Fantastic. And for comparison, here are 2 of my solder joints on the metal cage. In this situation, the key to good solder joints is a high enough temperature. And I actually had to set the temperature of my soldering station all the way to maximum for this.